going to do a brief introduction to the homework just to make sure that we're approaching it in the right way. We're asked to graph sine of x. This is a graph that I want you to be comfortable with. And so you should be able to reproduce the key coordinates, the minimums, the maximums, those midline points for sine of x. And so if you don't remember, spend a little bit of time refamiliarizing yourself with sine graphs and also with a cosine graph. And so I've graphed that here with its key locations. And it asks us to graph from negative pi to 2 pi, so that's what I've done. Right, then we're asked to solve for a shaded region represented by that definite integral. So the first part is to make sure we know that that means the area between the sine graph and the x-axis, between those two x values. And then hopefully next we remember how to solve for these definite integrals. We want to do the antiderivative of sine, which is negative cos of x. And we're going to evaluate it from 0 to pi. That means that we're going to do negative cos of pi. And then we're going to subtract negative cos of 0. Again, I encourage you to be comfortable enough with a unit circle to be able to solve for this. But cos of pi is equal to 1, or sorry, is equal to negative 1. So a negative 1 gives us a positive 1. Cos of 0 is equal to positive 1. So I am subtracting a negative 1 because of the negative sign. Gives us a value of 2. And hopefully that's kind of a cool result, even though we've got this very unusually shaped area. The answer to its area is actually quite clean. It's an area of two blocks. Okay. Next, we'll just do one or two of the problems below. And here, make sure you are actually reading the instructions closely enough. You could solve these 3 problems exactly like we just solved the one above, except the question tells you that you may not use the fundamental theorem of calculus. Well, to understand what this means, we need to know what the fundamental theorem of calculus is, and the fundamental theorem of calculus is all of this stuff that we just did up here. So you are not, according to these instructions, allowed to use antiderivatives. You are not, according to these instructions, allowed to plug in your starting and stopping value and calculate the area in that way. Well, how would we do it? Instead, you might ask, well, the instructions do give us some hints. We want to use the graph and use what we know about sine, graphs, and integrals in order to solve these. So let's see how that works on the first one. First problem asks us to find the area from pi to 2 pi. Pause the video, shade that area on your graph, make a guess at what you think it is. Now that you've had a chance to take a look at that, the area that we are talking about, let me get a different color here, is this area here, from pi to 2 pi. Well, this area should just be the same as that area because of the symmetries of the sine graph. However, it is below the x-axis. And areas that are below the x-axis are negative areas. So this is negative 2. We did not need to do the antiderivative of sine. We did not need to plug in 2 pi. We did not need to plug in pi. We calculated the area just by reading the graph. If you were to do the fundamental theorem of calculus, you would get the same result. And if you want to go check to make sure, check and make sure. I will do one more. Here we're being asked to find the area from 0 to 2 pi. Well, that means starting here and stopping here at 2 pi. So that means we want to do it, these two areas put together. Well, this area is 2, this area is negative 2. So if we put these two areas together, we get 0. So that definite integral is equal to 0. So the goal with all of these problems is to approach them in this way. All of them you should be able to calculate by reading the graph and reading how either the graph is changed or how the start and stop values on the graph are changed. So go ahead and try the remaining 7 problems on your own, and we will talk about them next week.